Now you need to learn how to name inorganic compounds. Nomenclature means rules for naming things. What we're not going to work with are organic compounds. The word organic comes from organism. That's a whole separate classification of compounds. The acetone, ethanol, diethyl ether, those are all examples of organic compounds. And we'll leave that for a later class. This is where we're living, inorganic compounds. I know that's not real helpful, just saying that they're not organic compounds, but we'll work through this. Here's two different minerals, epsomite and mirabilite. Epsomite is also known as Epsom salts, and mirabilite is also known as Glauber salt. Well, for a long time, compounds were named for many different reasons. Sometimes they were named because of a nearby town where they were discovered. That's what happened with epsomite. It was named after a nearby town in England called Epsom. Sometimes they were named after people. The discoverer for mirabilite was Glauber, so that's why it's called Glauber salt. Sometimes they were named because of properties. All sorts, like I mentioned, all sorts of reasons. And then you had some really confusing things. Sometimes you had different names which described the same compound. And then other times you had different compounds described by the same name. Not useful at all. And Epsom salt and Glauber salt doesn't actually describe what's in it. Incredibly difficult for students to try and memorize all of those. We are using IUPAC rules. And the idea behind IUPAC rules is, instead of using common or trivial names, people, places, whatever, we develop a system of rules, and this system has to describe what's in the compound. So no more people's names. Up until the late 1700s, there had been a number of attempts to revise chemical nomenclature, but there was a publication in 1787 by Gaëtan Lavoisier, Berthollet, and Fourcroy, which kind of put together the major efforts at the time, and they tried to standardize the naming rules. Over the years, it turned into different things, and eventually we ended up with the International Union of Pure and Applied Chemistry, which is a worldwide organization, and one of the things they work on is chemical nomenclature. I'll put a link at the end of this podcast where you can go and you can actually download a number of PDF files that are IUPAC publications that describe the rules for all sorts of things. And we're going to use something called the Red Book, 2005 edition. We're not actually going to use the Red Book. If you go and look at it, you'll see what I mean. It's difficult reading, but it does very carefully lay out the rules. Let's go back to our minerals. Epsomite is actually a hydrate of magnesium sulfate. Mirabilite is actually a hydrate of sodium sulfate. Now, if you look at the chemical formula, each down there at the bottom, ignore the .7H2O and the .10H2O. That just means that they're hydrates. We'll deal with hydrates in lab, but we're not going to worry about naming hydrates in lecture. So MgSO4. Mg is magnesium. SO4 is sulfate. Magnesium sulfate. The name describes what's in the compound. Na2SO4. Na is sodium, SO4 is sulfate, sodium sulfate. Now we have a set of rules that describe what's in the compound. The types of compounds we're going to be dealing with, at least right now. One type will be binary molecular. Binary means two. Molecular means that you have two atoms bonded together, and a good generalization right now is one of them's a nonmetal and the other one's a nonmetal. So for example, carbon dioxide, CO2, carbon to oxygen, nonmetal to nonmetal. I'm making a command decision here, and these are from my classes. We're going to treat germanium and antimony as if they were nonmetals. Even though they lie to the left of that zigzag dividing line on the periodic table, when I was searching through publications to find compounds for naming, it seemed to me that germanium and antimony compounds were more often named as if they were molecular compounds. Lying along that dividing line means that in the case of these two, they have properties that kind of blend metals and nonmetals. So, command decision for me and for my classes. We'll learn binary ionic compounds. So ionic, you look at the two atoms that are bonded together. One will be a metal, the other one will be a nonmetal. Again, it's just a generalization, but it works pretty well for us. Calcium chloride, CaCl2, metal to nonmetal. And we'll also work with polyatomic ionic compounds. Polyatomic means many atoms, and the ionic is a certain type of compound. If you go back to the magnesium sulfate and the sodium sulfate, those are examples of polyatomic ionic compounds.